Hi, I am Charan. My topic is anomaly detection. This is my presentation. The contents to be discussed are what is anomaly, types of anomaly, why machine learning for anomaly detection methods, machine learning algorithms for anomaly detection, and applications. Finally, conclusion. So now, what is an anomaly? Anomaly detection is one of the most common use cases of machine learning. Finding and identifying outliers help to prevent fraud, adversary attacks, and network intrusions that can comprise your company's future. Uh, in the in this presentation, we will talk about how anomaly detection works, what machine learning techniques you can use for it, and what benefits anomaly detection with ML bring to the business. Uh, this is a simple example. Here we can see O1, O2, and O3. These dots are anomalies. These are different from N1 and N2. uh, an anomaly is nothing, uh, generally speaking, an anomaly is something that differs from norm, deviation, and expectation. In software engineering, by anomaly, we understand a rare occurrence or event that doesn't fit into the pattern and therefore seems suspicious. Here are some examples: sudden burst or decrease in activity, error in the text, sudden rapid drop or increase in the temperature. Common reasons for outliers are data pre-processing errors, noise, fraud attacks. Uh, I will illustrate in this example. In this example, we can see penguins, and one penguin is odd in this. The yellow one is the odd penguin. So this penguin is called anomaly. Detecting it is called anomaly detection. In this, we can see all the red vehicles and a yellow car in it. Here, the yellow car is an anomaly. Uh, this is anomaly detection. Comparison. When you give the values manually or statically, machine learning gives has a high scale, and it is very quick in execution with a very high accuracy. But the only disadvantage is cost of implementation is high, and it is uh, low to maintain. Types of anomalies. So we have three types of anomalies: global outliers. Uh, when a data point assumes a value that is far outside all other data point value ranges in the data set, it can be considered a global anomaly. In other words, it's a rare event. For example, if you receive an average American salary to your bank account each month, but one day get $1 million, that could look like a global anomaly to a bank's analytical team. The second one, contextual outliers. When an outlier is called contextual, it means that its value doesn't correspond with what we expect to observe for a similar data point in the same context. Contexts are usually temporal, and in same situation observed at different times can be not an outlier. For example, for stores, it's quite normal to experience an increase in customers during the holiday season. However, if a sudden boost happens outside of holidays of sales, it can be considered as contextual outlier. Coming to the third one is the collective outliers. Collective outliers are represented by a subset of data points that deviate from normal behavior. In general, tech companies tend to grow bigger and bigger. Some companies may decay, but it's not a general trend. However, if many companies at once show a decrease in revenue in the same period of time, we can identify a collective outlier. Now, what do we need? Why do we need machine learning for anomaly detection? This is the process that is usually conducted with the help of statistics and machine learning tools. The reason is that majority of the companies today that require outlier detection work with huge amount of data like transaction, text, image, and video content, etc. You should have to spend days going through all the transitions that happens inside a bank every hour, and more are generated every second. It is simply impossible to drive a meaningful insights from the amount of data manually. Moreover, another difficulty is that the data is often unstructured, which means that the information wasn't arranged in a specific way for the data analysis. For example, business documents, email, or images are examples of unstructured data. Machine learning used for real world application helps to streamline the process of anomaly detection and save the resources. And s- and save the resources. It can happen not only post factum but also in real time. Real time anomaly detection is applied to improve security and robustness. For instance, in fraud discovery and cyber security. What are anomaly detection methods? There are three types of anomaly detection methods. They are supervised, unsupervised, and semi-supervised. Uh, the first one is supervised. In supervised anomaly detection, an ML engineer needs a training dataset. Items in the dataset are labeled into two categories: normal and abnormal. The model will use these examples to extract patterns and be able to detect the abnormal patterns in the previous unseen data. In supervised learning, the quality of the training dataset is very important. That is a lot of manual work involved since somebody needs to collect label examples. Coming to the unsupervised learning, this type of anomaly detection is the most common type and most well-known representative of supervised algorithms are neural networks. Artificial neural networks allow to decrease the amount of manual work needed to pre-process examples. Example, no manual labeling is needed. Neural networks can even be applied to unstructured data. Neural networks can detect anomalies in unlabeled data and use what they have learned when working with new data. The advantage of this method is that it allows you to decrease the manual work in anomaly detection. Moreover, the architect of the neural network is a black box. We often don't know what kind of eventual neural networks will label as anomalies. Semi-supervised learning. Semi-supervised anomaly detection methods combine the benefits of the previous two methods. Engineers can apply unsupervised learning methods to automate feature learning and work with unstructured data. However, by combining it with human supervision, they have an opportunity to monitor and control what kind of patterns the model learns. This usually helps to make the model predictions more accurate. Machine learning algorithms for anomaly detection. Multiple machine learning algorithms can be used for anomaly detection depending on the data set size and type of the problem. The first one is local outlier factor, LOF. Local outlier factor is probably the most common technique for anomaly detection. This algorithm is based on the concept of the local density. It compares the local density of an object with that of its neighbors data points. If data point has a lower density than its neighbors, considered as an outlier. K nearest neighbors. KNN is a supervised machine learning often used for classification. When applied to anomaly detection problem, KNN is useful tool because it allows to easily visualize the data points on the scatter plots and make anomaly detection much more intuitive. Another benefit of KNN is that it works well on both small and large data sets. Support vector machines. Support vector machine or SVM is also a supervised machine learning algorithm often used for classification. SVM use hyperplanes in multidimensional space to divide data points into classes. The hyperparameter is the threshold percentage for outliers, which you have to choose manually. SVM is usually applied when there are more than one class involved in the problem. However, in anomaly detection, it is also used for a single class problem. The model is trained to learn the norm. You can identify whether unfamiliar data belongs to this class or represent an anomaly. DB scan. This is an unsupervised machine learning algorithm based on principle of density. DB scan is able to uncover clusters in large spatial datasets by looking at the local density of the data points and generally shows good results when used for anomaly detection. The points that do not belong to a cluster gets their own class, so they are easy to identify. The algorithm handles outliers well when the data is represented by non-discrete data points. Autoencoders. The algorithm is based on the use of artificial neural networks that encode the data by compressing it into the lower dimensions. The ANN decode the data to reconstruct the original input. When we reduce the dimensionality, we don't lose the necessary information because of the rules have already been identified in the compressed data. Now we can already discover outliers. Bayesian networks. Bayesian network enable ML engineers to discover anomalies even in high dimensional data. This method is used when the anomalies that we are looking for are more subtle and harder to discover, and visualizing them on the plot might not produce the desired results. What is anomaly detection used for? Now let's see the applications of anomaly detection in practice. So, intrusion detection. Cybersecurity is for many companies that work with confidential information, intellectual property, and private data of their employees and clients. Intrusion detection systems monitor the network to detect and report potentially malicious traffic. IDS software notifies the team if suspicious activity is detected. More examples are software by Cisco Systems and McAfee. These are other three detections: fraud detection, health monitoring, defect detection. Fraud detection with machine learning helps to prevent activities aimed at obtaining money or property unlawfully. Fraud detection software is used by banks, credit organizations, and insurance companies. For example, banks check loan applications before making a decision. If the system detects some of the documents are fraudulent, for example, that a tax number doesn't exist in the system, it will notify to the bank employer. Health monitoring. Anomaly detection systems are incredibly helpful in healthcare. They help doctors with diagnosis, detection, unusual patterns in MRI and test results. Usually, neural networks that have been trained on thousands of examples are applied here. And sometimes they give a more accurate diagnosis than doctors with 20 years of experience. Coming to the defect detection, manufacturers can lose millions in lawsuits applying for clients with mechanisms or mechanism details that have defects. One detail that doesn't correspond to the production standards can cause a plane to crash, thus killing thousands of people. Anomaly detection system that use computer vision can detect if the detail has a defect even among thousands of other similar details on the belt line. Moreover, anomaly detection usually can be connected to the mechanisms to monitor internal systems such as engine temperature, fuel levels, and other parameters. As discussed, these were the applications of anomaly detection. And challenges of intrusion detection are traditional signature-based intrusion detection systems are based on signatures of known attacks and cannot detect emerging cyber threats. The real-time anomaly detection is a credit card fraud detection. Uh, it is as I've explained, it is also used in healthcare informatics. Finally, conclusion. Anomaly detection is identifying the data points that do not fit in the pattern. It can be useful to solve the many problems, including fraud detection, medical diagnosis, and also the belt line, whether the product is defect. It can be also used in agricultural fields, detecting MRI and images. Machine learning methods allow to automate anomaly detection and make it more effective, especially when large data sets are involved. Some of the common machine learning methods used in anomaly detection include LOF, autoencoders, and Bayesian networks. Anomaly detection can detect critical information in the data as well as high applicable in various application domains. Nature of anomaly detection problem is dependent on application domain, need different approaches to solve a particular problem formulation. Thank you.